If they choose.
Yep, sounds good.
All right. Well, welcome to the GIST Forum. I'm Stephen Challam. I'm an ontologist with Semantic Arts, and I'm going to be talking about our GIST 14 release that we put out about 2 weeks ago. I'm going to start with an overview of the GIST ontology, and this is the GIST Forum. I think people pretty much know what GIST is. Nonetheless, I want to touch on some of our sort of design principles and kind of overall purpose with GIST to set the scene, and also maybe for the benefit of anyone who is new here or who may be watching this on our YouTube channel and not have all of that background. I'm going to spend most of my time talking about the GIST 14 release and how it differs from GIST 13. And then I'm going to talk a little bit about what is a GIST release, what is our process for releasing GIST, and finally, what are some of the ways of exploring GIST? Because I think there are some resources that people, even people who've been a little familiar with it, may not be aware of. I can see everyone on the screen here, so feel free to raise your virtual hand if you have any questions or comments while I'm talking. Okay, so GIST is, we call it a minimalist upper ontology for the enterprise, developed and maintained by Semantic Arts. What we mean by ontology is spelled out here. It's just a way of organizing information in a given domain. And in the context of semantic data, it provides the meaning within a knowledge graph. When we talk about an upper ontology, so an ontology can cover a very specific area of a business. It can cover a very specific domain of knowledge, or it could be more general. An upper ontology is an ontology that serves as a foundation for what we can call extension ontologies. And the purpose of it is to give an overall structure so that when someone's building an ontology, they're not starting with a blank text editor. They've got kind of some general concepts to hang things off of. And also, if a company is building more than one ontology, basing them all on the same common upper ontology really helps with making them interoperable, so that knowledge graphs that are created on the same upper ontology can be queried together. We refer to enterprise because this is specifically a business-oriented upper ontology. Some of the upper ontologies out there are more intended for scientific use. Some of them have a more of a philosophical foundation and are more abstract. We aim specifically at things that are useful to businesses, meaningful within businesses, and terminology that's generally understandable to business people. And finally, minimalist. We keep GIST as small as we can while still covering everything we want to cover. There's about 200 concepts in GIST, which means that someone can reasonably expect to get to know, kind of get an overall understanding of it fairly quickly and hold a lot of it in their head at once. At the same time, we're minimalist in the sense of not dictating how people do things. We want to, as much as we can, leave flexibility in how people use it. Our ontology is based on World Wide Web Consortium standards, and it's the ontology itself, along, of course, with the standards, is open source, and we make it free to the world and invite contributions from the world. GIST is OWL2DL compatible, which says something about the kind of reasoning that can be done, the kind of automated reasoning that can be done from it. We publish it in 3 formats, 3 different ways of serializing or expressing RDF. and we author it in Turtle. We use Protege as an authoring tool, but a lot of our work is just done in a text editor in the Turtle language, which is the most kind of human readable serialization of RDF. So GIST 14 is a major release, and I'll talk a little bit later about what that means. But the essence of it is that it contains breaking changes. So there's someone who's using GIST 13 and wants to migrate to GIST 14 may need to make changes in their data or in their ontology. We released via GitHub. So, we also make this, of course, available through the Semantic Arts website, but the official release, the sort of canonical version of the release is on GitHub. This release has 96 classes and 115 properties. So as I was saying before, about 200 concepts overall. And it's not much of a change from GIST 13 in terms of the overall count. Part of our minimalist philosophy is that because we're always adding concepts, we're also always looking for places we can streamline and remove concepts or combine concepts. Not going to go through this in detail, but I want to give a sense of the broad effort that it takes to make this happen. One of the main ways that GIST grows and evolves is through our consulting practice. We have a lot of clients who use GIST, and when we're doing that real world work, we come across things that clients may need or benefit from that aren't currently in the ontology. So many of our ontologists regularly contribute to GIST. We also take a lot of input from this group and from the broader community who uses GIST. We're very open to listening to and incorporating the ideas that other people bring to us. So I mentioned we release on GitHub. If you want to really go to the source and make sure you've got the real thing, you can go to the GitHub page. We have a download package there that's zipped up. We also have the source code that was used to put together that release if you really want to dig into the guts of this. So as I said, this is a major release, and when we talk about a major release, we don't necessarily mean that it's a large release, although this one is both large and major. We use the SEMVer numbering systems and the SEMVer concepts of major, minor, and patch releases. So a major release is a release that has breaking changes in it, where somebody can't just drop it in place of what they're already using and necessarily expect everything to work. We do provide some tools to help people who want to migrate. A minor release is anything that adds something new to GIST, something substantial new to GIST, but doesn't break anything. It is backward compatible. So this is where there may be something that's minor in this sense that's pretty large or significant in the usability of GIST. So I just kind of wanted to make that distinction. I think I said we use the SEMVer numbering idea. If you can go to semver.org and learn everything about that. So the biggest changes in GIST 14, we added a class called Knowledge Concept. And I'm just going to run through these quickly now because we'll go through them more in detail. We added a assignment class and a couple of predicates that accompany it. We did a very thorough pass at the annotations, the definitions, the scope notes, the examples, and really made sure that all of this is following our best practices and that it's uniform and informative, that the definitions are concise, and so forth. We introduced a more nuanced model of offers and the predicates that go with those. And we did some streamlining in the overall class hierarchy, particularly at the highest levels. And also I'm not going to be going today a lot into the formal semantics within GIST, but we have some newly established or newly documented best practices, and we've gone through and made sure that everything we're doing in GIST adheres to the best of that. Another thing that has kind of accompanied the GIST 14 release, not formally part of it, is this periodic table of GIST. We're always looking for ways to explain what it is we do here. And this is an ongoing attempt to kind of provide a very high level overview and some organizing principles from GIST. I'm not going to be going through this in detail, but it is on the Semantic Arts website, and as I said, it's a work in progress. But we're hoping it'll be another useful way of getting people into the mindset of GIST. And I'll be using, you'll notice the coloring here, I'll be using some of those colorings throughout the rest of this presentation. So, the biggest changes, of course, are adding and removing classes. And again, I'm not going to go through this on this slide in detail because that's coming up. But I did want to point out that there's kind of a balance in what we add and what we remove. We don't want this to grow bigger and bigger and bigger, and so we're very conscious of not allowing that to happen. So the first big thing we introduced is knowledge concept, and this came out of an insight from Dave McComb, our founder and CEO, that there's this whole world of knowledge management that is pretty separate from our world of knowledge graphs. And there are things that are of concern in that world of knowledge management that didn't really fit well within the concepts we had defined in GIST. So a good example, so a knowledge concept is abstract knowledge that arises from experience. So one of the examples that Dave likes to use is, Judge Smith. We know that Judge Smith is lenient towards repeat offenders in the morning, or we know that the first killing frost of the year in Fort Collins comes in September. So in those cases, we've got something concrete to hang that information off of. Judge Smith is a person, Fort Collins is a city, and so forth. But sometimes we've got things that we want to record knowledge about that are harder to fit into concrete categories. So the example I use here is gene. We can, in the genetic sense, that if we want to talk about an actual gene in a specific person's body, that's a pretty concrete object. But if we want to talk about a gene in a general way, we don't necessarily have a place to hold on to that concept. And so so that's something that's potentially a knowledge concept. Just for your information, the FOXP2 gene is the speech and knowledge gene, and the TAS2R38 gene is the cilantro tastes like soap gene. So some knowledge is about specific instances that already have a place in a knowledge graph, but some things don't. So another example here is gold. So we may have a specific, we've got a particular gold coin or a particular vessel of molten gold or something, and those fit the definition of a physical substance, gold. But if we want to say things about gold in general, gold has been valued throughout history. Gold is a symbol of wealth and permanence, whatever. That concept of gold could be a knowledge concept. Could be an instance of some subclass of knowledge concept. So I'll pause here for a moment and just ask if there's any questions, comments of anything up to this point. Michael.
Yeah, in this case, the concept of gold, a knowledge concept, would that be like an umbrella over the physical instance of gold?
Yeah, I think that's a good way of looking at it.
I mean, okay, so the concept of gold, and it may have set one or more physical, or not physical, but concrete variations of it.
That's right.
Yeah. Okay. Cool. All right, and then you would link them through SCAs, or you wouldn't make them subclasses? I mean, how would you link them?
Well, I mean, in the first instance, if we have something we want to say about gold in general, and not about a particular piece of gold, we would use predicates to attach that to the knowledge concept of gold. As far as how we would connect a particular instance of a particular physical instance of gold with that concept. I
mean, is that a taxonomic relationship, or is it or that changes depends on the nature of these relationships?
Dylan or anyone else, feel free to jump in here if you got something to add. But this is
I mean, in a weird way, the example you're giving, I would say the physical gold, it would be would be SCAs broader to the knowledge concept of gold. I mean, that's how I'm reading it, but of course, I'm just throwing that out there just to get the discussion going. But whatever.
Yeah, I think you're right that there are a few different things there. There are the individual instances of what we would call physical substance, like a particular hunk of gold that we can talk about and make assertions about. And then there is the knowledge concept, which, as Stephen pointed out, we can make general claims about, gold in general. There's a further link that we could establish between that particular hunk of gold that we want to talk about and the general concept of gold. And it may depend on the use case, what predicate we would want to use to link those. It could be maybe as based on or as categorized by, depending on the concept. But certainly we could establish that link to kind of codify that relationship in that way.
Sure. Yeah. I mean, I can see this going a long way towards helping disambiguate, because, pretty much every word in English has multiple meanings, and some of them are abstract and some of them are concrete. So yeah, this is great. Thanks.
Mark?
Hi, I'm Mark Johnson. I want to just introduce myself because none of you know me. I was invited here by Dave. I worked with Dave McComb 25 years ago, the years before GIST and around the time they were developing the semantic web, actually, a little before that. And I'm super interested in this because I work at NIH and I work in an area where we have lots of computers, and I need to do data integration across our runtime systems. So that's me. I'm in Bethesda, Maryland right now.
Welcome.
And thank you. This is interesting. I get the sense that gold as a physical substance is something that would have a generic molecular weight, for example. If it's like a subclass of, a physical substance that is uniform in composition, right? So it would have a molecular weight. Whereas the knowledge concept doesn't have a molecular weight. It would have notions, for example, of it's valuable, or it's reflective, maybe, or if you were doing an ontology about history, it might be like one of the things that would move, across the ocean because it's valuable, right? So you're talking more on that level of conceptual notions of gold, not in its physical manifestation, but rather like everything else about it. So,
Mhm.
yeah. Okay.
All right, so the next major change I want to talk about is we removed the class, the top level class artifact. And this was a very broad class that covered pretty much anything that's human made. And we were finding that it was so general and so broad that, there was nothing much that could, there was nothing really useful that could be said about it in and of itself. And it encompasses so many things that it wasn't useful as an organizing principle. So that's something we removed. And so some of the things that were subclasses of artifact were also subclasses of other things. So equipment and building were subclasses of artifact, but they were also directly or indirectly subclasses of physical identifiable item. So we just kind of let those alone. They already had a place in the hierarchy. Joaquin.
Yeah, I don't want to introduce too much tangential conversations, but I see that these breaking changes are pretty significant. Will this be reflected in the GIST derivatives and the other kind of domains that we modeled out, or?
Yeah, and that usually, so you're talking about maybe the subgists or some
Yeah,
of
just
the
computing or anything like that.
extension domain. Yeah, I mean, there's usually some lag there, but these changes will filter down to those others. And I'll actually talk a little bit about the migration process a little later on. But many of the concepts or many of the classes that were subclasses of artifact didn't already have a place. So a few of them were promoted to being top level concepts in their own right. And then we introduced a new top level class composite to bring in a couple of the things that were previously just under artifact. And just to kind of summarize those a little bit. So, we have several things here. These are all the classes that were previously under artifact. Some of them just moved right to the top level. Some of them found new places in the hierarchy. And some of them already had other places to go. And I'm just going to keep moving, but feel free to pop your hand up if you have a question. So what this does at the very top level of GIST is despite removing a very broad top level class in artifact, we're actually ending up with a little bit, one less class at the top level. So a few things got moved down out of the top level. A few things we added a class that consolidated some of the existing things. And that was kind of part of our overall effort to streamline the highest level of GIST. The next big set of changes was in the geospatial area of GIST. One just lexical change. We changed the name of place to geolocation just to make the naming more uniform so that everything in this geospatial area begins with geo. And we had a few things that we had previously as subclasses of place, landmark, and georoute that we've decided are really more a landmark has a place, is in a place, but is not itself a place. So we remove that association to reflect that. And same with the geo-route. A route goes from a place to a place, but is not in itself a place. And then finally, geosegment, we removed because it's really just a special case of geo-route, that a segment is just a very simple route that goes from one place to another, whereas a route may have many places, many waypoints along the way. Mark.
Yeah, so what I noticed in your geolocation in 14, you've got 0, 2, and 3-dimensional representations of space.
Yeah.
And the 1-dimensional, which I guess is a geo-route or a segment, has just been deprecated.
Well, no, the route has not been deprecated. It's no longer, it's now only a subclass of ordered collection, but there actually is there's some formal semantics that connect them. And I'm not showing it there, but there is a formal relationship between a geo-route and geopoint.
So you'd use properties to essentially define a sequence of point to point.
Correct.
Yeah, which is different from using that same mechanism to create a polygon, essentially, that could define a georegion or a geovolume, because that would be very hard to process.
Yeah, that's right. We don't directly make that connection.
Yeah.
So a geo-route is an ordered collection of geopoints.
All right.
It's a set of geopoints that are in a particular processed or visited in a particular order. And you're right, we don't take the additional step of saying these regions together define a volume, or these points together define
great.
a route.
Yeah, you could, but it would be hard to use.
Yeah.
Okay, thank you.
Sure. All right. So the next thing
I want to say
ahead.
nice meeting you all, and I got to drop because I've been summoned to another meeting. So
well, thank you for
I'll watch
joining.
the rest of this online. Yeah.
Yeah, thanks
you
for
again.
joining.
Thanks a lot. Bye.
All right, so another new class here is composite, and I think it's a pretty common sense idea, but we had a few things already that could be subclassed under composite and found it useful to create a covering class for them. So composite itself is a very general idea. We don't expect there actually to be direct instances of composite. The instances would be typically of instances of subclasses of composite. And this is something that's just anything that's made up of other things. And what this allowed us to do was kind of bring some structure and order to this idea of aggregation. We have this new class of composite. We have a class component that was previously a subclass of artifact and has been promoted to the top level. And there are some parallel structures between this, and I've shown a little bit of the formal semantics that connect these, so that a network link by definition belongs to some network. Same with a network node. There's also some formal semantics defined between network nodes and network links, that a network link by definition is something that connects network nodes. And then same with ordered member. An ordered member, by definition, is part of some ordered collection. So this kind of introduces a nice parallel structure of the ways things can be aggregated. Okay, the next major area we introduced was assignment, and this is really a new concept in GIST. There's a lot of cases where something is assigned to something. So a person is assigned to a task, a room is assigned to a group of people, and so forth. We may not know who did the assigning. We may not know everything about it, but part of its definition is that someone does the assigning and something is assigned and it's assigned to something. So just a little bit of the formal semantics here. It's a temporal relation, meaning that it's potentially applicable within a period of time. So a person's assigned to a project for a certain year, for example. Someone makes the assignment. We use the has giver predicate for that. There's something being assigned and something or someone that it's being assigned to. So we introduced the assignment class, and then along with it, the assignment of predicate that connects the assignment itself to what it is that's being assigned. And typically that is used, typically the domain for that, the subject of that, the object of that is an assignment. I just got that backward again. And typically the things being assigned can be things like equipment, intellectual property, organization, person, but we're using the gist domain includes here and range includes rather than the RDFS domain and range, because we want to keep this open. There are, we use the domain includes and range includes to kind of give some idea of how, of some of the ways that it can be used, but in the spirit of minimalism, we don't want to restrict people to only using it in that way. So we keep that open. And in parallel to that, we have assignment 2. So we've got something being assigned, and then we want to be able to say what or who is it assigned to. Typically, the subject of this is going to be the assignment, but again, we don't restrict this predicate to only being used in that context. So our next major change within GIST 14 was with the class offer. This is a class that already existed, but it was structured in a way that kind of limited it to the use of offering something for sale. So, I'm offering my car on eBay for $3,000 or something like that. We saw applications for more general things, particularly for trades or swaps, and offers to buy things as well as offers to sell things. And so we made some changes here to kind of generalize the concept of offer. We removed the requirement that there be a monetary value associated with it, and this is to accommodate things like trades or barter. And we created some more specific properties. So there was a property offers, and we removed that property and put in 2 new ones, offers to receive and offers to provide. So offers to receive is what the offer is asking for in return for something. So usually that would be money, an amount of money, but it doesn't need to be. And then let me just address the next one, Joaquin, and I'll get to you. And then offers to provide. What is the thing that we're offering to give in exchange for what it is we're proposing to receive? Go ahead, Joaquin.
So this would be a consideration as part of a contractual agreement?
It could be. Yeah, I mean, that would be certainly one application. It could be just, if you're, listing something on eBay for sale, or if your company offers something in its product catalog. There is a contractual context to that, but this isn't necessarily going to be used in the context of a contractual agreement.
We had a question also in the chat.
Oh, okay.
Can a top level class is part of or has super category child to parent relationship to another top level class? For example, can two components realize a composite or a physical identifiable item?
Yes, what I mean by a top level class here is just that it has no defined superclass. It's not a subclass of some other class, but there's no limitation on how that can be used. And going to that example, a component can itself be a composite. We don't say that. We don't place that limitation on it. So you can certainly say that so we gave the example for composite of a library, that a library is it can be a collection of books, but you could also have a library system that's a collection of libraries. There's nothing that says something can't belong to more than one top level class, or that that top level classes can't have that kind of relationship to each other. Michael Eschold, you're on mute if you're speaking.
Sorry about that. Yeah, the property is assignment to. I expect that its domain would include person or organization, but you didn't indicate anything about that in the slide.
Yeah, we don't. We have the domain includes assignment. We don't currently have a range includes on assignment 2.
So, because I would have thought the intention would be most often you would assign it to a person. Is that correct?
Yeah, I think that's fair to say. I think that would probably be a useful thing to add.
Okay, thank you. Thank you.
I think there's a wide range of things that could go in the object position there. I think organizations where people would certainly make sense, and for that reason we might add that range includes assertion, but also things like projects. I know we mentioned like pay rates and billing rates and things like that too. So it's potentially a wide range of things, and that may be why we didn't initially add that range includes assertions.
Do we have examples in the annotations? Because that would be helpful.
Yeah. Yep.
Okay, thank you.
Javed.
Yeah, hi, Stephen. So not on this slide, but the slide you had on the collection, ordered collection. I was a little bit, I was thinking about it. Yeah, this one here. I was not clear about having an ordered member being a member of ordered collection. It seems like the order itself is captured twice at the collection level, at the member level, and it seems like, if I'm not wrong, then if that's the case, then ordered members cannot be used out of the context from this member collection itself. I'm thinking about out loud, like like a bookshelf. Okay, there's a book, there's a list of that number of books, and they're ordered. Fine, but can't I talk about that one book out of the context being of that that ordered books? I'm a little bit confused. Yeah, I'm not sure. Like being ordered member be part of the ordered collection. I'm not. Doesn't resonate with me.
Well, so we do have more than one way of ordering things, and we have a sequence number or a sequence predicate, and if we simply want to say where something falls within some order, then we can assign it a sequence.
So talking about that, right? So you say different ways to order the same thing. So if one thing is part of two different collections, and it is ordered differently.
Right. So okay. So that's an interesting point here. So the ordered member is a proxy for the thing being ordered. So, because the same thing can fall within different positions in different sequences. So an example we often use is the finishers in a race. If somebody, if the New York Marathon, Alice, Bob, and Charlie come in first, second, and third, and then in the Boston Marathon, Bob, Charlie, and Alice come in first, second, and third. The same three individuals, but different orders in different contexts. So the ordered collections there would be something like Boston Marathon top finishers 2025 and New York Marathon top finishers 2025. And we'd have Alice, Bob, and Charlie as people. And then we'd have ordered members that serve as the proxies for those people in those two different ordered collections.
Okay, so ordered members will be linked to the sequence number as well as the person. Is that
correct?
How you think?
Correct.
I see. Okay. So, yeah, all right.
Did I answer your question, Javed?
Yes, I understood the model itself, but I was just a little bit. Yeah, it's one way to model it. Yeah, my understanding was the ordered member itself is the member of the collection, or it's not a proxy. Like if the people, there are three people, the ABC, they all link to the collection, and then you give a sequence to them. But yeah, okay, no, I think you're right. Need to perform.
Yeah, we had to introduce, because something can be in different positions in different.
Yes.
The same person or same object can be in different positions in different collections. If it's important to capture that, we introduce that proxy entity.
No. Yeah, I got it now. Okay, thank you.
Sure. All right, so the next change I want to talk about is in the area of agreements and commitments. The big clarification we made here, so we used to have agreement as a subclass of commitment, and in discussing this and clarifying our thinking on it, decided that a commitment is from one party to another. It's a one-sided or one-directional kind of thing, whereas an agreement is a mutual commitment between two or more parties. And so we made agreement and commitment both subclasses of intention, rather than one being a subclass of the other. And obligation in that case is really covered by commitment. So we don't, so we dropped the obligation class. We don't need a separate class for that. The next change was is produced by. So we had the property produces, and a while back, I think it was just 12. We decided to not maintain inverse relationships. So wherever we had a pair of relationships where one was the inverse of the other, we would choose just one of those to include in GIST. And we established some rules of which one we would choose. Generally, we choose the child to parents direction. We try to choose the one that will produce the least amount of triples, the least amount of query results. And we had just produces and decided that really we had made the wrong choice there, and is produced by would be a better predicate. So we just replaced that one with its inverse. One of the things we do in GIST to assure or to help with logical consistency is declaring some things as disjoint. You know, we try to keep this to something of a minimum because we don't want to limit how people use this. But if there are things that are clearly would be confusions or misuses of classes, we declare them as disjoint. And in that spirit, we introduced 6 top-level things that event is disjoint from. I mentioned earlier, we did a pretty thorough pass at improving the annotations. So, you know, we had some where we had many where the definitions weren't really concise definitions. They included usage information in them. They included examples within them. So we split that out and made the definitions as tight and concise as we could, and then moved some of that information where it was valuable into separate example annotations or scope note annotations. We made sure that all of these annotations that were written over the course of many years were adhering to our current best practices. And just to give you a sense of the scope of this, about 3/4 of the classes had some changes or improvements in the annotations, and more than half of the properties. Just to give you some concrete examples of that, we had, agreement defined as something which 2 or more people or organizations mutually commit to do. We improved the wording a little bit on that, but then we also added some examples of where that's used and some scope notes to clarify how it's intended to be used. Similarly, we had this pretty weak definition of has recipient of the recipient, and we brought that into our current best practice of defining a predicate by how it relates to things, and then we filled that out with some examples and some detailed scope notes. And these are just a couple of instances we made these kinds of improvements to many, many properties and classes within GIST. So I was asked earlier about breaking changes. So these are all the changes we made that could potentially break queries or break extension ontologies, render data invalid. And for any breaking change we make in GIST, we provide some kind of mitigation strategy. We have a semi-automated migration process, a set of scripts, and some code that executes those scripts. And so in some cases we can clearly replace them. So simplest example, we renamed place to geolocation. So our migration script just goes through, and anywhere it finds just place, it puts in geolocation in its place. We removed the taxonomy class, and I haven't mentioned that yet, but taxonomy was a subclass of controlled vocabulary. We decided there wasn't any important distinction we needed to create there, and that we would just eliminate taxonomy. And then anything that's been declared as a taxonomy, we just move that up and change that to controlled vocabulary. Same with the is produced by. If we have triples where we say, A is produced by B, or A produces B, we just our script replaces that with B is produced by A. Where this property is used as a subject or object, which is a less common situation, but might be used if somebody is subclassing or subpropertying the property, we just report that that's happening. And because there will be a decision there by the modeler of how they want to handle that. And same with the remaining ones here. We can't always predict how somebody might want to mitigate that, but we do have, if somebody runs our migration process, it will flag for them all of the places where those eliminated things are being used, or where, in the case of the disjointedness, where things have been made, have been rendered invalid, potentially. All right, so I wanted to talk just a little bit about the release process. If you take a look at the GIST repository in GitHub, you'll see that it's fairly close to what's in the release package. So the things that actually happen in going from that subcode to the release package, we run some checks on it. These checks are also run throughout our development, but we do a final test of making sure that everything is logically consistent, that everything is syntactically following our rules. And then we do some things that are helpful for various tools that people use with ontologies. So there's some places where subclasses can be inferred, but not all reasoners are going to make those inferences. And so we go through and we add explicit subclass assertions where those can be inferred. We add, generally our annotations use SCUS, but there are tools that rely on having RDFS. I'm sorry, I'm referring to the wrong thing here. So we add RDFS is defined by annotations to everything that's declared in GIST, so that these are traceable of where they come from. I mentioned that we authored GIST in Turtle, but as part of our release process, we create RDF XML versions and JSON LD versions of everything for people or for tools that work better with those. Our documentation is all authored in Markdown, but we, as part of our release process, create HTML versions of all our documentations. And then there are some things that are part of our development process that are not really of use to people who are simply using GIST. And when we package up GIST for release, we remove those. I'm going to move through the remainder of this pretty quickly because we're down to our last few minutes. But if you take a look at the release package, at that web download zip, you'll find 3 top-level directories: docs, migration, and ontologies. The documentation, we have some documentation for some specific areas of GIST that are somewhat complex. The way we handle addresses and the way we handle units of measure, in addition to the general documentation for GIST. And again, we have it both in Markdown and HTML format. The migration directory contains those tools I mentioned for some scripted assistance to migration from the earlier versions. And then the ontologies, GIST core is the ontology itself, and some people, that's all they'll really need, that's all they'll use. But for knowledge graphs that make use of our media types, we have an ontology file for those. And then we have some additions to GIST that are kind of logically implied, but that are useful to some tools and can be included for people who want to use those. So getting your hands on GIST, there's a few ways to do that. You can download the release package either from GitHub or from our website, or you can load it directly from a URL. We've got a server that just serves up the GIST file. If you want to contribute to GIST or really want to explore deeply how our development process works, it's an open source project. You can clone the GIST repository on GitHub to a local repository of your own and work with that as you please. Ways of kind of getting to know GIST to explore it. If you've got Protege, it's an open source tool. You can download it for free. You can open GIST from the individual files that are extracted from the package, or you can open it directly through that URL I mentioned. And we've got a few kinds of documentation we generate, which I'll go through. Opening in Protege, you can simply say in Protege, open from URL and specify the official URL of the GIST ontology, and then we'll load it directly in. That's just an alternative to loading a Turtle file or other file from your file system. Protege gives you kind of a nice view. One thing that Protege does that none of the other ways of viewing it do is the axioms are given in Manchester syntax, which is more plain language, more readable to many people than the Turtle versions of things. So it's something that's just handy to know it's out there. The documentation, we've got the ebook that gives the information that's organized into kind of logical groupings, what we're calling constellations of classes and properties, provides exhaustive diagrams for each class with all of their semantics spelled out. We've got this Widoko documentation generated using a tool called Widoko that's very easy to search. Everything's linked. It's all one HTML page, easy to share around, and a version that generated called with a tool called WebVowel that gives you a visual way of exploring GIST. So with that, I think we're right at the minute here. I'm happy to stick around if anyone wants to raise any other questions or comments. All right. Well, thank you everyone for attending.
Oh. So this version is in effect. Migration's available to facilitate this. There are some changes that need to be brought up to speed with BFO and GIST mappings, and sub-GIST domains are going to be updated as well over time.
That's right.
Jonathan?
When do you think the BFO mapping will be done to GIST 14?
That's
Not a commitment, just ballpark.
No, yeah, I think that should be sometime soon, probably within the next month or so. There will have to be
Cool.
some consideration of where those new classes will fall and that kind of thing.
Right.
But overall, not a huge effort, so should expect to have it out there soon.
Cool. Thank you.
And these changes are also supportive of the data-centric accounting book that Dave wrote as well, right, Stephen?
Yeah. I'm not sure offhand if there's any GIST 14 being used directly in that, but it's certainly all compatible.
Well, sorry, I mean, the concepts of making promises and fulfilling promises, having those considerations being reflected in these new classes.
Yeah, again, it's been a little while since I read the draft of the book. I'm not sure, but yeah, certainly those do align with the kinds of things that are covered in the data-centric accounting.
Yeah, that definitely aligns. We have commitments that we keep track of for every business process and then the fulfillment of those commitments. So definitely.
Well, thank you, Stephen, for the wonderful presentation. If anybody has any other comments, otherwise, yeah, I'll stop recording now. I think it was
Thank
so
you.